assessment of friction and wear of surface coating. Now, let us see what is the significance of low friction and high wear resistance for a mechanically functional coating, and this is going to be a requirement for a mechanically functional coating, in that there will be a sliding between two parts, and these are known as tribopair. So, it is in fact the tribology of this coating, and that simply by that we simply understand that it is actually the friction, wear and lubrication aspect of this coating. Now, one thing we understand that this functional requirement of any mechanical component. So, we now consider a mechanically functional component, and there for any mechanically functional component we can draw such graph, and on the x axis, that is the time scale, or what we can call life of that part, service life, and on this, that is actually the wear of the part. Now, mechanically functional means we can put this in this category, all the mechanical components subjected to this kind of friction and wear. It can start from conventional slide guide, it can be screw nut, it can be cam follower, even it can be any cutting tool or a forming tool, where continuously this tool is subjected to high load, high speed and even temperature. So, these are the environment under which one mechanical component has to work, and in that case this wear and time. So, that graph, that means the progress of wear with time, that limits the life of a component, and it is obvious that for reliability of service we have to limit somewhere the wear. Say this is the limit, and that is the magnitude, and how quickly this part or the component reach that limit, or how long it is for this part to reach that particular limit. So, it can be even, it can reach very quickly or it can take a long time, and there we find immediately the surface property of that part, which is in continuously rubbing action, say a bush and the journal of that particular shaft, which are also in continuous sliding rotation, say screw and nut. Now, in this case, wear means wear on the screw or wear on the nut. Now, when it is the bush bearing and the journal, that is the portion of the shaft which is inside that bush and which is rotating, if there is wear and if it exceeds certain limit, and that limit is set by the operational requirement, and that is actually specified by the designer of that component, considering the safe operation of those parts. And here this limit is the given on wear, and at the same time what is also important to understand, that this is friction or say coefficient of friction, and this is also time. So, when we have two elements of a pair, say A is in contact with B, that means this is one component of the tribo pair and that is in B. So, A and B, it may be screw nut, it can be cam follower, it can be two gears, it can be surface of the cutting tool and the chip. So, always there is A and B in continuous contact, and because of that, which is very important to hold the geometry of the important component, and at the same time it is also necessary to reduce the coefficient of friction to its possible lowest value. It is obvious that when they are rotating, that frictional force and as a consequence of that power loss due to friction, that is of immediate attention to one application engineer. So, from metal selection point of view, it is obvious the choice will be obvious to have the surface of A and surface of B. They are designed and formulated in such a manner that the friction value becomes very low. So, here also we have scope of all sort of research development, that means between A and B what will be the coefficient of friction, and it can go like this or it can be above this value or it can be low, and it may even change with time. If we have some surface modification on A or on B to have the desired effect on this value of mu, which should be brought down at any cost, and also where rate has to be brought down, and this is the limit, and this limit can go up or go down depending upon the stringent requirement, or where we can be little bit liberal to set the value of wear. Whatever may be the case, here also we can see a graph for any mechanical component. It follows like this and then it goes like this. So, this is more or less the presentation of a wear graph. That means, at the very beginning it starts with a high rate and then the rate slows down, and this portion which is more or less straight, and that is actually mechanical wear zone. This is initial break-in zone, and here wear takes place, where occurs at a very fast rate. Now, the thing is that when it is the question of friction and wear of surface coating, one has to look for a particular coating on a surface, say the component A and B. Maybe on the component A we have to have proper surface modification, either in the form of coating or just by changing the physics, the basic features of the surface of that particular component, so that the part A with coating with B in contact, then the curve can also take a different shape, and our objective will be always to flatten this or to reduce this initial rate. That means, the rate of increase will be as low as possible. Now, here what we find, few of those parameters which can affect this thing, and this can be summarized or highlighted here. That means, these are the factors which in general affect friction and wear. If we consider only the mechanical characteristics, it is going to be hardness and modulus of elasticity and also fracture toughness. Now, when it is the body, two bodies in contact, it is also adsorption of that surface. It is a tendency to adsorb get adsorbed, and it can be a physical phenomena or a chemical phenomena, and that may greatly affect this particular friction and wear. Now, chemical reactivity, adhesion to that particular surface and having a chemical reaction, making a bond formation, and that will resist or restrict the movement, and at the same time because of this reaction a part of the material can be removed, because it will lose the basic property of that component which is submitted to this high speed, high load rubbing associated with maybe high temperature, then maybe an environment where this wear is also augmented. So, this particular environment can also favor rapid wear. So, these are the thing one should look at, and here the chemical reactivity is one of the particular issue. Now comes surface roughness and apparent area of contact. From our common understanding, we can feel a surface is smooth or rough, and without looking into the chemical aspect or metallurgical aspect, that means metallurgical affinity or chemical affinity, even we get a feeling that rough surface means it is going to give higher value of friction force, resistance to motion, and as a result, as a consequence, there will be higher magnitude of wear, or the growth of wear may take place at a higher rate. So, this surface roughness, definitely it is a geometrical characteristics of that particular surface, and along with surface roughness, rougher the surface, apparent area of contact and true area of contact. So, these are the thing coming in picture, will definitely those are the thing one has to consider. And then comes load. These are the external input, that means the normal load under which these two parts are working, then comes the sliding speed, then temperature and environment. Environment means if it is a humid atmosphere or dry atmosphere, if it is a oxygen rich atmosphere, or it is under normal vacuum, or if it is under ultra high vacuum. So, taking those factors which are highlighted here, definitely one has to find out what is going to be the friction and the wear finally, which determines here this wear and friction, and finally, they are going to decide what will be the service life and the level of performance, and whether that particular A and B, it is a good matching tribo pair which favors proper functioning of the mechanical component, or they are not at all matching pair and they should not be screened as one of the tribo pair, favorable tribo pair. Now, various tribo pair we can look in. Actually, when we talk about this friction and wear of coating, it is in fact it is actually the whole idea here. This is a one step in the process of characterization. Now, in the characterization, we have seen how this hardness value may affect the quality of coating, whether it can be selected or it needs not a coating for functional use. Similarly, this is also this step, this is also going to be one of the screening step and a ranking step. So, what we can do at best, that in this tribological test involving this two component which are having some modification of the surface, with a coating or without a coating. So, they have to be tested, and this test is some sort of a simulation test, and that we shall discuss in the following section. But let us look into various tribopair which we can see in commonly what we can identify and see in practice. One is simple pin on disc. That means, this is a disc, this is a disc and which has one axis of rotation, and then on that we can put either a pin or a ball, and of course, there are all peripheral arrangement, so that they are properly fixed in fixture, and it serves like a apparatus. So, this is a pin, and this pin is loaded with a force P, and this is an RPM N, and this is the contact, I mean this is the radius where this pin is in contact, and instead of that pin we can also have one ball. So, this is going to be a ball which also have to have a ball holder, and the principle of operation would be same. So, this is RPM. So, there will be a load, and this is the radius. So, this is called either pin on disc or ball on disc. So, whole idea here that this disc which will be coated. So, on this coating this ball will be held, or the pin will be held against with a force, and then they will be allowed to rotate, and in this case we expect this wear resistance or weakness in wear resistance, whether they can give a good value of friction or a very high value of friction. So, all those preliminary information can be generated, and this will be a very important test in screening, that is the preliminary screening of those tribopair. That means, whether they can be used in actual machine building as component for reliable service and performance of the machine. Now, pin on flat, what is exactly mean by this pin on flat? This is going to be actually a table like look like, and here what we have on this, it can be a pin, so here what we see, this is actually flat, this is going to be the top view, and then we have the pin here. So, this is actually reciprocating. Here it is unidirectional rotation, and here this pin is stationary with a force P in contact with this table, and that is a reciprocatory motion. And here also this pin or the ball, those are stationary, and this disc is rotating. We can also have similar thing with the disc. So, this will be something like, here we can show from the top view. So, this is the disc, and here we can position the either the ball or the pin, and then it instead of a continuous rotation, it will have a oscillatory motion, say through quarter of a turn. So, this will be an oscillatory motion, it will reciprocate, and as a result of that, this will move forward and in the reverse direction, and there we can expect this sliding mark. So, this is another example of oscillatory sliding using one disc. Then pin on cylinder. Now, pin on cylinder means this is going to be a cylinder, and this is the axis of the cylinder which is rotating. Against this we can have one pin and which will be in contact. So, this is one way, and here we have the front view. So, this is going to be the pin that is in contact. So, this is example of pin on cylinder, that means the pin held against cylinder and that is stationary and loaded with a force P. Now, flat on cylinder. Now, this is something like this. Here we have a cylinder. So, this is rotating, and from two sides we can hold two flat plate from two sides, and if we see the front view, it looks like. So, this is going to be the orientation. So, this is actually flat on cylinder. So, these are the flat and loaded with the force P from both ends. So, this is also another tribo pair. Now, comes a thrust washer. So, in thrust washer what is done? One washer will be held stationary. So, this is one washer with this center line, and this will be held against this one which is rotating. So, there will be a thrust force. So, the top one will be held against a force against this one. So, there will be the contact force, and the bottom one that will be rotating. So, this is also another tribo pair. This is stationary and this is rotating, but both are just like washer. So, this is actually thrust washer. Cross cylinder. Cross cylinder, they can also form one tribo pair in that. So, this is one cylinder at the top, and at the bottom this is another cylinder. So, they are at a right angle. So, this is stationary, the top one is stationary. So, here we have the load, and this bottom one that is actually rotating. So, this is also another tribo pair. So, this is a cross cylinder. So, that we can see. This is also used for assessment of friction coefficient or the friction force and that of the wear. Now, 4-ball tester. 4-ball means actually if we see the top view, then we have 3 balls here. This is the top view, and then we have the third one. It is something like this. So, that is the top view, and all are resting on a horizontal plane. And if we now consider the front view. So, front view, considering the front view, what we are going to get here. So, this is going to be this cylinder. So, that means this is A, this is B, and that is C. So, this is A and that is B, and C is behind A and B, and here what we have to do? We have to bring the cylinder D. So, that means this is going to be a cylinder here, and this is going to be a cylinder like this, and this will be actually a cylinder which will keep on rotating and the force will be supplied from this side. So, this is also one tribo pair where this top one D that is actually rotating, it is having a sliding speed and this is supported by A, B and C. So, this way also 4 ball constitutes one tribo system where also one can assess the friction force and also the wear in the tribo system. So, these are the various tribo pairs which can be used. Actually, this is going to be a simulation test simulating the actual situation for which is prevailing in the actual engineering system, and just for selection of the material for making those components of the actual system, we have to carry out a simulation tribological test. It is for ranking or screening the particular tribo pair, and this is here what we are considering the material aspect, whether material wise whether that selection is compatible and selection is justified and we have a proper selection. So, it is simulation test for friction and wear. Now, one thing we have to definitely here careful that this simulation test means as close as possible to the actual system and actual condition. Otherwise, this will lose its purpose and relevance. That means, where it is the force, the velocity, sliding velocity in and also the environment and also low temperature or high temperature tribology, that has to be also taken into consideration. The coating, whether it is going to be used at high temperature or room temperature or a moderate temperature, whether this coating is going to be used in severe humid environment or it is going to be in the dry environment, whether it is going to be in high vacuum. So, all these should be arranged and all these conditions should be maintained to make this test meaningful and the results useful. Tribometer. Now, this is actually the machine where or the apparatus where we can carry out the tribological test. Now, tribological test, now this is done, this can be carried out in a pin on disc, we call it pin on disc machine or ball on disc machine. This is a common thing in all sort of tribological assessment of coating or any component which are under sliding or rolling contact, and this is actually the tribometer. Now, basically in tribometer what we have a table and this table is a rotating table. So, on this rotating table with proper fixturing we have to have the holding of the substrate. So, this is the substrate and here we can put this substrate, and all these are standardized considering this international understanding that all these tests should be conducted under a well set, well specified condition, so that these results can be compared, results can be analyzed, and from there we can find out the meaningful results, meaningful observation which can be useful for further use of these results in actual application. So, this is going to be the specimen and this is the disc, and this is a rotating table. Now, on that table what we are going to have here, we can have a pin or a ball. So, let us consider this to be the pin, and this pin will be actually held inside a pin holder, and this is actually one arm. This arm is pivoted at this point. And here what we apply, that is the load. In most cases a load means this is actually a dead load is applied. It can be, say for example, it can be as low as 1 Newton or millinewton, it can be as high as few tens of Newton. It depends upon how we are going to simulate the situation following the actual system or actual condition. So, this selection of the load and selection of this RPM, and then what we find here clearly that this is going to be the radius, that means the radius, sliding radius. So, here what we find, if we consider the top view, so we can find, say this is the location of the pin. So, pin is in contact at this radius and this is the radius r. So, depending upon the radius, RPM can be changed, and here this load is fixed for a particular assessment. And what we have here, actually this is the normal load, and for this is going to be the circle which will be followed by this point which is submitted to sliding. So, this is the circle which will be followed by this point of contact between the pin and the disc, and ultimately a wear track will generate on this surface. So, first we can see a line appears, and then this line will increase its width about its mean position. That means, this is going to be wider with passage of time, and this we call the wear track on the disc, wear track. So, this wear track will be a continuous ring like thing, and this one can recognize on the top view. And what is important to know, in the direction at this point, this is the sliding velocity, and this is also the direction of friction force, which we can show by this symbol F. So, this friction force has to be continuously monitored, this friction force. So, this friction force has to be continuously monitored, and then F by n, that is going to be the coefficient of friction, or say in this case this is F by P. P is actually the normal load. So, this is actually coefficient of friction. Since P is constant all through, so coefficient of friction, that will be a true reflection of the friction force, or friction force is reflected by this coefficient of friction. So, here two things we can look at, that this force has to be continuously monitored, and on this arm it is almost like a elastic member. That means, it subject itself to some kind of very precise close, restricted deformation, and in that case what we have a strain gauge type sensor, that is a transducer. It can be LVDT type, linearly variable differential transformer, or piezoelectric type your sensor or transducer that can measure this friction force with highest possible precision to have capturing the data, which will be very useful for analyzing the whole performance of the coating. So, this is actually the this strain gauge piezoelectric type or LVDT that will be put here, and in this direction as the force is acting, that will be recorded in this direction, in the direction of velocity, and that is exactly the job of this tribometer, continuously monitoring and recording the force of friction. Now, this is a rotating specimen. We can have a rotating specimen continuously rotating, or we can have reciprocating specimen. Now, as we have already mentioned, if we consider just one disc, this is a disc. So, either it can rotate continuously or it can reciprocate. Similarly, what happens? We can have a load which is constant or which is variable. This is particularly important, this variable load, that is also to simulate one real life situation. That means, this tribometer, that is to be one versatile machine, versatile device to simulate most of the situation as they do exist in practical life, and it is where we try to simulate this situation. That means, in reciprocation, say for example, the reciprocation is from 0 to 90 degree, say this is the start from where it reciprocates and it goes to 90 degree and then coming back to its original position, and here we have the load, normal load. Now, what we can put? Normal load, say for example, like 2 Newton. So, 2 Newton from the very beginning, from the start. So, as it starts reciprocating, we have a 2 Newton load. However, when it makes about 80 degrees, it is 0, it is 80 and 90 degree, 1/4 of a turn, and then moving back. Now, when it comes to 80 degree, say for here this is 80 degree, the load should increase immediately. So, that has to be arranged in the tribometer to simulate a very special situation as demanded, and in that case what we can see that in this tribometer, this is the pin, and then we have this arm, horizontal arm, this is the pivotal point, and that is the extension of the arm, and here say we have the disc which is actually oscillating. So, this is actually a oscillating over say 90 degree as we have shown here. So, here what happens? Here we have a point support with a ball, and just below that we have one electromagnetic device, and which will be energized in this direction, this electromagnetic device, and which will force this transducer to apply extra 18 Newton. So, this 18 Newton comes from this side, it is an additional load, and this load is applied when this rotation, when this oscillation is just up to 80 degree. That means, when this rotation has taken place through 80 degree, immediately there is an activation. that means there are all what we call these capture switches are there. So, the one switch is here and this is another one. So, at the moment when it comes to 80 degree, immediately this is activated and the load is applied, and this is actually 18 Newton. 80 Newton. So, total load applied between 80 to 90, that becomes actually 20 Newton. So, this is continuously this way it is working, and after moving to 90 degree, that means this limit again it is brought back to 2 Newton. That means, this load is 18 Newton that is withdrawn. So, this 18 Newton that is set by the transducer, and for that what we have here one electromagnetic coil, and that current has to be set in such a manner that this transducer only exert 18 Newton, and that will be recorded here, and accordingly the current setting has to be done here. So, that 18 Newton is displayed in the display unit, and which is the force exerted by this piezoelectric transducer. So, this is also another very special application, and this is also to simulate a situation where in actual condition load is actually it is a reciprocating device, where at the end of the reciprocation, almost at the end of the reciprocation, the load which is applied against the disc, that keeps on changing, and that is increased to a higher value. Now, here what we can see, that in normal case we expect a wet track of uniform width. However, when it is this type of system, a special tribometer, this is for a conventional tribometer, and which is has a unidirectional movement, but when it is this reciprocatory tribometer with alternate sliding, in this case we do have the disc, but here reciprocation is restricted only to 90 degree, and what would be interesting, up to 80 degree we have a wet track of this width, because the load is now 2 Newton, and then from 80 to 90 within this 10 degree, because now the load is 20 Newton, the shape of this wet track that will be little bit enlarged. So, we expect this enlargement of this wet track over this, and that will be recorded, and also the friction coefficient of friction, that should be also measured from for 2 Newton, that means for 0 to 80 degree it is for 2 Newton normal force, and we have a friction value mu 1, and from 80 to 90 degrees this is going to be 20 Newton, and for that we have a friction coefficient that is mu 2, and the instrument should have proper electronics hardware to capture those signals. One is corresponding to 2 Newton normal load, and in the last phase it is going to be friction coefficient which is corresponding to 20 Newton. So, we understand this constant load, variable load, alternate sliding and unidirectional sliding. Evaluation of performance of the coating. Now, this evaluation of performance of the coating, here actually what we see, that it is actually the coefficient of friction, and on this side we have the time, and it is a standard practice to put 0.3 as the life of coating. That means, when this coating friction coefficient exceeds 0.3, then we can say the life is totally exhausted. That means, for a matching tribo pair, one has to keep the friction value well below 0.3, and a good tribological coating can give a value much below 0.1, and that is the performance level of a tribological coating. So, here we can see that from the initial stage, it may so happen that this friction value goes up as it starts with this normal load. It can go up and then it can fall, and it can go like this, and finally, depending upon how this coating survives and how does it last, there can be some partial fracture of the coating, and that will be recorded like this, and then it goes like it goes up, and this means that the coating is removed. So, what we actually meant to say here, that this monitoring the value of friction with time, that gives a clear indication about the performance of the coating as reproduced or as pictured by this tribometer. And at the very beginning, this coating shows a very high value, and this may be a phase what we normally call running in period. So, the geometry of the pin and that of the coating on the disc, they adjust itself, and once that is stabilized, it come to a very good value. Now, this to get a very good value, obviously at the very beginning what we have said, that roughness of the substrate surface, then its high points of surface asperities, apart from the chemical inertness or very low chemisorption, those conditions are there. Hardness of the substrate, that should be also properly monitored, and that should be also properly taken care of, and then only a tribological coating at the top of that it can work. But this map clearly shows how good or how poor the coating is and how long it can survive. So, looking at this graph, one has to find out different graph for the same coating. It can be a PVD, physically vapor deposited, or CVD coating. It can be galvanic route. It is a particular material, and also the structure of the coating as it is, it develops because of the synthesis process, whether it is in the fine atomic scale or it is grain coarsening. All these matters will come in picture apart from the basic roughness of the coating. So, this is one thing one has to look in this total map, friction versus time. Now, measurement of wear and wear coefficient. Now, this wear coefficient actually, as we see the wear track, and if you see the cross sectional view, what you can find, that this is going to be the cross sectional view of the coating. If it is the frontal cross sectional view, in that case this is actually the coating, and what is the wear, what is the volume that is removed from this wear track, and this volume can be calculated. That means, wear volume on disc. This is one wear volume on disc. So, this is one of the thing one can measure, and then what we have to also look in, that means the normal load, that is the normal load which we express as N, and also the distance travel. This we can express as time, but this can be also expressed as, say for example, by so many meters. So, this is the distance travelled by this pin. So, this is also one way. So, now it is Newton meter. So, Newton meter. So, wear volume, that is in millimeter cube divided by Newton meter, and this Newton meter, Newton means the normal load here and how much distance it has travelled. So, that we know as the wear coefficient for the disc. Similarly, for the pin, it can be pin or the ball. So, this is the original shape of the pin. It has certain radius, but because of the wear we can have so this is the pin. Now, because of the wear this area may be removed, it has disappeared. So, on the pin what we get, on the pin what we get, it is something like this, it is an wear flat area. So, this is actually the area that is called wear flat. So, this wear flat, so from this width of this wear flat diameter and this depth, that is also calculated, this volume can be also determined. So, the wear volume on pin divided by this Newton meter, that means this normal load travelled a distance of so many meters. So, wear volume, that also is given by millimeter cube per Newton meter of this distance travel and the normal load. So, from this we can have fair assessment of the wear performance or wear resistivity, wear resistance, and also at the same time this friction. So, this is one of the thing one has to look in. Now comes, if it is a reciprocating sliding, in that case what happens, we can illustrate quickly this too with time, and this is continuous sliding and that is reciprocating sliding. A rough coating, there is a fair chance that initially it may be rough and it can come down because of this running in period and smoothness. So, it is moving in the same direction and we have a smoothening effect, but when it is a reciprocating coating, there is the chance, there is a risk that it can go like this and it will not come to a very, assume a very low value. So, chances are remote. The reason is as follows: if it is a reciprocating coating, in that case the rough surface on the coating which is on the substrate. So, there is the sliding force which is force of friction and it is actually changing its direction. So, these columns which are acting like column, they are subjected to this alternating change reversal of the force, and this is exactly called brushing effect. And because of this brushing effect, there is every risk that this coating architecture, this coating which is built up here, that can be torn here and ultimately that whole coating will be removed and force will be quite high. So, when it is a otherwise rough coating which is produced by any vapor deposition process, it is important to smoothen it or to polish little bit and then only to put in alternating sliding. But when it is unidirectional sliding, in that case after a initial rise it can come to a very low value of friction because of this running in and smoothening of this coating. So, this way we can look into this various aspect of tribometry, that means the measurement, the science and engineering of measuring the coefficient of friction, then the resistance to wear of the coating, and for a particular coating the behavior, it can vary depending upon the structure of the coating, crystallographic orientation of the coating, and sometimes the coating is also sensitive to humidity. A particular coating which runs and works excellent, its remarkable performance is well noted under high vacuum, that shows a very poor performance when it is just a humid atmosphere. Similarly, a coating which cannot work under a light load work pretty well under a heavy load. Similarly, a coating which cannot work at a low speed can work at a high speed. But in some cases we do also need coating which can work under heavy load and low speed, because in those cases there is chances of stick slip and jerky motion, and which is not very stable, and that will create problem for micro movement of any mechanical device. So, as a result of that, what we find the problem in those mechanical system. So, naturally in those issues we can determine or we can rank the coating according to the requirement, and this requirement may be high speed one extreme, it can be low speed high load, it can be high temperature, it can be high vacuum, or it can be oxygen atmosphere, or it can be even humid atmosphere. So, with all these aspects taken into consideration, this measurement of the coefficient of friction and the wear on the coating, these are definitely a guideline for ranking and screening the coating, so that finally those materials can be properly chosen and selected, and one of the best tribo pair can be engaged in building the actual mechanical system and mechanical device. So, with that we can make a summary of this discussion, that pin on disc or ball on disc machine known as tribometer is commonly used to assess tribological performance of a coating. The test conducted in tribometer is a simulation of the actual situation, and an effective simulation requires acceptable similarity between actual system and the test specimen and condition. The test can be effectively used for ranking coating material for functioning at different condition of load, speed, temperature and environment.